Okay, this is our last example for this section. We are going to form the solid of revolution in the coordinate plane. So it says sketch and describe the solid that is produced when the region enclosed by y equals 0, y equals x, and x equals 5 is rotated around the x-axis. So let's go ahead and just graph those pieces to start us off. So let's see, I'm going to try to make my axes thicker. I'm going to try to differentiate so you guys can see a little easier these pieces. So there's my x-axis and my y. Draw the arrows on them. Ooh. There we go. Don't know what was up with that one. All right, labeling the pieces, we have y equals 0. So that's going to be a horizontal line. No matter what x is, y is always 0. So there's that first piece. And then x equals 5, which means that at 1, 2, 3, 4, 5, we've got that piece. And then we have y equals x. So that's this line this way. So we graph the three pieces. What the problem says, it says the region enclosed by these three things is rotated around the y-axis. So if you look, this little triangle that's enclosed by all three is what we're going to be rotating around the y-axis, which is that vertical axis. I'm trying to solve this. Okay, so once you go ahead and do that, and draw that enclosed region, like how I drew it, obviously my little pieces are a little out of there, but for the most part that fits. So that means we're going to be drawing it around this piece, which means it's going to go in that mirrored place. So reflected across the y-axis, that's going to be there. And shade that in. Sorry for the gaps in my talking. Give us a second to shade. Okay, so we've got that piece. And then we're going to continue circling it around. We're going to build that out, bring it in a little bit. Okay, so what you see right there is we can now connect the pieces and then curve down the bottom, because that also has a curve when you round it around. Okay, so the solid, what the solid is that we've created, and that will be filled in, is a cylinder. However, there's a cone chunk removed. So if you see this shape, that's a 3D cone that is cut out of our cylinder when we circled it around, okay? So our cylinder is that piece, and then that cone is missing. So we need to find the volume of the solid, which means we need to find the volume of the cylinder and subtract the volume of the cone from it, okay? So we need to go ahead and look at all our pieces. The first thing that we know is that our radius is 5 units, because this is at 0 and then we went 5 over. So our radius is 5. Because our axes have this line of y equals x, it goes up and over 1, up and over 1, up and over 1, which means by the time it hits 5, it's 5 tall. So our height is also 5. So you can see that through this piece, and then you can see that 5 is across, which makes it a lot easier to work with. All right, let me minimize this a little bit. Okay, so volume of a cylinder is pi r squared h. So pi r squared h, and that's of a cylinder. And then it's a very good cylinder. And then the volume of the cone is 1/3 pi r squared h. Okay, so pi times 5 squared times 5, that's the volume of the cylinder. And now we need to subtract that cone that's been pulled out of it. 1/3 pi, then r squared h. So if you look at that, they're all the same. It's 1 minus 1/3. So it's actually going to become, if you look at it, this is 1 minus 1/3 of it. So it's going to be 2/3 pi times 125. Or you can, break it apart and do it by hand. But if that's a 1 and that's 1/3 of the same thing, then you have 2/3 left. That's 250 over 3 pi. Plug that in and you get 261.8 units cubed. So you can say it's approximately that, or approximately 250 over 3 pi. And that's it for your last problem. Hopefully that made some sense. I hope the visual wasn't too rough. But yeah, that should be good for this one.